I always like to start with the history. So Chris, can you give us a little, like, you've been around a while, and I guess we've all been
Actually, we'll
around
let
a
Kirk
little
do
bit.
the history. Kirk, go ahead and take that away, because he's the one that really has dug in and loves the history of this and has dug
Great.
into it.
So for those that don't know it, the first HVAC control system filled an entire room. We quickly adopted pneumatics because they already had that strategy in other places, and they thought it was the wave of the future. Due to its sheer size, they realized very quickly that it had to be reduced. So in 1914 was really the first one that did it, and I'm sure we all know the company that it was. But they came out with that system, and it was extremely complex. It took a couple people to operate.
Wow.
And now, if you think about, Tony, you made the comment about your house. I mean, how many of us control stuff from cell phones nowadays? Right?
Yeah.
So to think that we went from requiring an additional room in a facility just to control some HVAC equipment to now we control entire buildings off cell phones is, leaps and bounds ahead. So,
yeah. So that 1914, is that the print facility that was being controlled, the humidity to keep the, it was like, that's supposed to be the godfather of the first commercial air conditioning system.
Correct. That was the first idea. And then again, they adopted pneumatics because they'd been around 100 years previously, right? And started adopting them for HVAC.
Oh, okay.
So,
I did not know that.
Yeah. Pneumatics came about in the 1800s. So early 1800s. Yeah.
Gotcha. Now we've got some pictures of some controllers here.
The old time clock. It's painful for me to see a time clock. I will say that thermostat on the right, I have that one in my house so that I can control the temperature. So we don't have the heating cooling issue you were talking about, Tony. That's why I have that thermostat bottom right corner. So if you're my age, I grew up in the 70s and 80s. We had the two on the left, in those years. And I remember the mercury in the little thing there, which I'm assuming expanded and connected to contactors. Is that what that mercury did? Yeah, the mercury, you'd watch the bulb shift and it would literally touch two metal plates. Mm-hmm. And those metal plates would either put it in heating or cooling.
Gotcha. Now I had
temperature of the spring.
What's that?
It was based on the temperature of the spring. As the spring moved, it would rotate that around for you.
Yeah. And tilt the mercury.
Yep.
Gotcha. Yep. That makes sense. Now I had a pool that had a couple pumps and had that timer on there in the middle, which I hated. It was really hard to work. So I should have probably got a digital one. So anyway, when we say electromechanical, how long which one of these are all the ones? I know which one is for sure is electromechanical. Are the two on the left considered electromechanical as well, or?
I would think they would still be electromechanical. Just again, like Chris said, the springs and it's metal contact closure that would cause the 24 volts essentially to pass to change the mode.
Mm-hmm. So electromechanical means it's got electricity and there's some mechanical gears or springs or something going on in the deal there. So now that came before or after pneumatics?
This all came after pneumatics.
Oh, okay. Yeah. So I'm going to go to this slide here. So when I started in the 90s, DDC was just starting to change out all the pneumatic stuff, like in the field. Like we get calls, there'd be a VAV box with pneumatic controls and we were changing it to DDC. So one of you guys give listeners, including me, because I didn't know much about it. I knew there was an air compressor somewhere and there was a bunch of tubes running around. Is that right?
That's correct. Yeah, there was the air compressor there, bottom left corner of that picture. That was the heart of the control system. And unfortunately, if that failed, everything failed. So basically, it just used pressure, and then very similar to electromechanical, it has plates that adjust and bleed valves and give you air pressure. And then that'll decide whether to be in heating, cooling, to run your modes. And you can actually see in the lower right picture, you can't make them out, but there's a couple pressure dials in there so that you can actually see the pressure in the system.
I gotcha. So it worked off of pressure rather than a digital signal? Is that how it worked?
Yeah.
Okay, so I have a question for you. You can clear this up for me. So when I was in high school, there were these sensors on the walls in the hallway, and I always heard air hissing out of them. Was that because of this system?
Yeah.
What was it doing? Like, what was the purpose of that? It wasn't supposed to do that?
No.
Okay.
That's the challenge in pneumatic. And honestly, that was a challenge when DDC started. having a system that has a single heart, like that lower left picture, right, that has a single point of failure. That was kind of the challenge when DDC first came out as well, because that was how it controlled. Now we've gotten much more sophisticated. Price points have come down. Chip shortages have ended, and you still have hearts in the system, but everything should be able to run independently. It's one of the big things we talk about and promote, is that if your heart goes down, everything else should continue to run. Well, in the pneumatic scenario, like Chris said, if it's hissing or it's bleeding, right, you're losing air pressure. Your system can't control correctly. There's nothing worse than chasing a leak because you can't always hear it.
Right. Gotcha. DDC systems don't really leak, so that's good.
They do not.
So speaking of DDC systems, so Chris, you want to go through what does DDC mean? And
well, we're going to sit there and talk about DDC in kind of an interesting light, is because DDC, basically digital control, direct digital control, but at the same time, we think about Kleenex. That's a brand name. DDC, we talk about BAS, we talk building automation, we talk a lot of different terms, which are all somewhat now kind of used interchangeably for, I now have a computer as the heart. That computer brain is now what is running and looking at all of the sensors and deciding what to do. And as Kirk was also alluding to, we're distributing the brain. So we'll have in devices where it's talking to the main central controller, but at the same time, if we lose connection with that central controller, it kind of keeps running where it was before. And so we don't have that same problem of shutting down. But yeah, we use a lot of different things. These are basically, we're taking contactors and relays and communication and digital signals and BACnet and LAN and all this different communication, and put in a computer to really understand what's happening in the building. And then depending on the programmer, because this is always the question, there's no such thing as a bad controller in the industry, is the way we look at it. But there are a lot of questionable programs, because you think about, we take a program and every single one of us have a fingerprint when we're writing a program. And that fingerprint is the way we like to program. But at the same time, we take the one we liked the last time that worked really well, we then copy and paste it and modify it. And when you're in that process of modifying it for a new application, you're likely to make a mistake. You're likely to miss something. And so we do have that process. So when you think about the controls, what's actually gotten more critical on controls, especially when we went to the automation side of it, is commissioning. Because we then have to check out, are the sensors reading what we would expect? Are they reading reasonably? And then based on that sensor, we want to drive it into a mode, and does it go into that mode? And you think about, we're just checking the box to say, all right, did our computer program have the right links and work the right way? Because we have a lot of sensors and a lot of inputs that we're having to evaluate to decide what to do to keep that precision, to keep that precise control, and to keep that efficiency coming together.
Great. So I love it. So let's pull back for just a second here for someone who this might look foreign to them, right? So I circled these two boxes here, which are actually the blank, as you get them, a blank DDC controller, which you can program, correct? Kind of like a hard drive, it's blank.
Correct.
Is that correct?
Yeah, it's completely correct.
So this in the hands of me is pretty useless, right? This in the hands of a Kirk or a Chris is a very powerful tool. And I think what Chris was saying, and I'll just summarize this way, the controller is the controller. Really the heart of it, or the brains of it, is like the experience of the person programming it, the ability to program it based on their experience. And my experience with that is, anything you read out of a book is great, but actually doing the hard applications, going out there, doing the commissioning, going through, why isn't this responding right? Why isn't this working? We got to tweak this. So it's a blank slate. It comes for you to be able to program it as you see fit per the application. Now there's some other things in this. So this would be like a typical DDC panel, which we would use to control a piece of air conditioning equipment, right? Like a complex DX unit. What else would we control with this panel, Kirk?
So this panel would typically be any sort of unitary controller you're looking at here. That's what the panel we're looking at this picture is. It's kind of one of our designs. However, the hardware that's in it has much more capabilities than just that singular point of being a unitary controller. It can be the acronyms that Chris started with. It could be a BIS, a BMS. It's a DDC controller. You know, the great thing about the product is that it is a blank slate when you get it. The most terrifying thing about the product for most people is that a blank slate when you get it. Like there's no program in there. It doesn't start building it for you. You have to build it from scratch. The benefit is after you've spent years, as Chris mentioned, after you've spent years building programs and getting comfortable with them, you actually kind of have a database, right? You have your own database for this is perfect for an ERU with 4 compressors, you know, running this. And so you just modify it from there. One of the great things about the DDC that really took us farther than with pneumatics is pneumatics or electromechanical. When we talked about them earlier, we were really only talking about a single point to make a decision, right? The thermostat makes a closure, so we go into heat, or the pneumatic reads high humidity, so we go into dehumidification. And that's all. Whereas with a system like this, you can have multiple variables to decide how to operate the equipment. So the controllability of this is pretty limitless, right? You're limited by your ability to program and by the sensors that you could produce. But we haven't found anything we haven't been able to build yet, right, Chris?
Not yet.
So we've had some that's taken some thought and taken far more hours than we thought it would, but we've always been able to deliver at the end.
Sure, which is part of any learning process, right? So that's the brain. So on the right here, I'm going to circle the, you know, these are the inputs and outputs, right? We're gathering data, temperatures, pressures, whatever, and we're doing some calculation in the hard drive or the controller, the DDC controller. We're putting outputs out to turn off and on different pieces of equipment, to modulate valves, et cetera. Is that correct? How that works?
Yeah, that's absolutely correct. So, you know, the left side, as you pointed out, Tony, is all inputs, and that's where we gather our information or our signals. And that could be anything from temperature to humidity, or even if you're thinking a mission critical facility, we could get notification that the generator kicked on, right? And so that we know we're running in a different state because we're obviously on backup for the building. And then that controls the outputs on the right-hand side. You know, and again, this is years of experience between me and Chris. This is, you know, designed, it's really a big thermostat once you get away from all the programming and the logic inside it, when you just think about the information you're gathering and how you're wiring it up. So it is
very powerful.
It's very
the art of it, if you think about it, is if you actually go back into the computer science and the degrees, they talk about a good control system. If you want to have ultimate stability, you can modulate one thing at a time.
Yeah.
Well, when you think about a building, when you think about an HVAC piece of equipment, we're never afforded the luxury of one thing modulating. Everything's modulating: the outside temperature, the outside humidity, the indoor temperature, the indoor humidity, the load, the people coming in and out, all the different valves. In the refrigeration circuit alone, we could have 5, 6, or 7 things all modulating at once. And so that's where that sophistication comes in. That's where in the controls realm, where the thermostat doesn't work the same anymore, because you have to get that all playing in concert. So the best building in the world, you think about the control system, it's the orchestra behind the scenes. It's that music that makes it work together, because during their warm up, it sounds awful. But once they settle in and they're working together, you have harmony. And that's really what the entire building automation system is really simply just, that's all it's trying to accomplish, is that simple task of how do we make it all work together.
And Chris, is that why commissioning is so important?
Commissioning is important because you absolutely, that's the conductor in some regard, but you also have to step back and say, we just need to make sure if I tell it to do this, it did that. Because you think about, there's a few IO, there's a few inputs, there's a few outputs. I was called yesterday about a project. They've been working on it for a really long time, trying to figure it out. And it turned out to be, instead of in wire terminals 29 and 30, it was in 30 and 31. Nothing worked. So, and it's just, they got the light right. So you look at it, it looks like it's in the right spot, but whoever wired it missed it by 1. And so simple things like that, that's what commissioning. And so instead of, I'm not starting equipment anymore, we're basically commissioning equipment to make sure if I tell it to do something, it does something. And that way we can actually make sure it does go through those right steps and we don't have those problems.
How many jobs do we do that actually have commissioning? Well, let's back up for a second. So this controller we're talking about, is not needed on every job, right? This is a very sophisticated, high-end type of controls, but it's great for this conversation. We're going to go back a little bit and talk about just standard configurable controls in a minute. But how many jobs do we do that have a control system equivalent to this that have commissioning on them today?
External commissioning, not enough. Maybe 20, 25% of jobs. Internally, we remote access and monitor, any of these custom controls projects for a few months to ensure that we're working, operating, and delivering the way we're supposed to, right? It's ironic when most people shy away from commissioning, and then you have people like me on my team and Chris, that we all embrace commissioning. We also know that the more commissioning you do, the less warranty calls you have. Right? It reduces the overall back end or the end phase of a project where you're running into issues. Commissioning may not always be the easiest thing to get through, but what it does for us is huge.
And I think that's a good note to just generally speaking, like if you're a consultant or you're a contractor, you're an owner, and you're going to do a complex controls job, make sure you choose a company because none of this stuff is going to ship out of the box and work perfectly, right? Because all these are one-off when you're doing complex control systems, right? All these are kind of one-off. You're learning as you go. So the ability to learn as you go, make adjustments, make tweaks is super important. So if you're in the HVAC business and looking to do a job that's going to require these controls, make sure you work with someone who's got that capability. We're not the only ones that do that. I'm just saying, like, make sure you choose someone who's not going to ship you something and you can't find them again.
Correct.
Right? You can't get them on the phone or something, because that's extremely important. So, okay.